Michael Irving. A visualization of the South Pole of Mars, where a huge lake of liquid water is believed to have been found last year. Credit, NASA. Last year we got some big news from the Red Planet. A huge lake of liquid water was apparently found beneath the ice at the Martian South Pole. Building on that, a new study has now examined how it might have gotten there, and concluded that there has to be an underground heat source for water to cool there. For that to happen, Mars must have had volcanic activity much more recently than is normally believed, and may even still be active today. Discovered using radar instruments on board the Mars Express orbiter, the liquid lake sits under 1.5 kilometers (0.9 miles) of solid ice, and stretches 20 kilometers (12.4 miles). It's far from fresh though. Huge amounts of sodium, magnesium and calcium salts are thought to be dissolved in it, which keeps it in a liquid state at temperatures well below water's usual freezing point. But the new study suggests salt alone can't be solely responsible. There must have been some source of heat for the lake to form in the first place. And buried under that much ice, the heat could really only come from below. Here on Earth, liquid water pools under ice sheets thanks to heat from magma under the crust. Decades of observations have shown that Mars was once a very volcanically active place, but it's generally believed to have been pretty quiet for the last few million years. For a lake of that size to still be present today, the researchers calculated that there must have been volcanic activity within the last 300,000 years or so, with magma collecting in a chamber some 10 kilometers (6.2 miles) below the surface. And with activity that recently, geologically speaking, there's a chance it's still happening now. This would imply that there is still active magma chamber formation going on in the interior of Mars today, and it is not just a cold, sort of dead place, internally, says Ali Bransom, co-lead author of the study. Of course, the team acknowledges that the original discovery of the lake may have been the result of misinterpreted data, so there's a possibility that there is no water down there at all. But for the new work, the researchers started by assuming there was, then working backwards to determine the conditions necessary for it to exist. And they are plausible. If there is water on Mars, it could help cut back on the resources that future astronauts need to take with them, as well as fundamentally changing our understanding of the chances of extraterrestrial life on Mars or any other planet. We think that if there is any life, it likely has to be protected in the subsurface from the radiation, says Branson. There are still magmatic processes active today. Maybe they were more common in the recent past, and could supply more widespread basal melting. This could provide a more favorable environment for liquid water and thus, perhaps, life. The research was published in the journal Geophysical Research Letters.